So Thursday we went over on how to solve linear inequalities. So today what we're going to be doing is we're going to be solving quadratic and cubic and quartics of polynomial inequalities. Okay? We're going to start off by doing it by graphing. So I want to know, when is the function x squared minus x minus 6, when is that less than and equal to 0? So if this was a linear function like we did on Thursday, you would just isolate the x and then you would figure out the range. Pretty straightforward stuff. Okay? It becomes a little bit more complex when you have degree 2, 3, and 4, and so on. So we're going to do this graphically. So graphically, all I want to do is graph this function. You pick up a graphing calculator, you go to y equals, you enter this into the function, and you're just looking at the graph, right? When the graph's above the x-axis, it's positive. When the graph's below the x-axis, it's negative. And when the graph is on the x-axis, it's equal to 0. Right? Makes sense? Okay. So I already graphed it for us with the wonders of technology. So there's the function right there. Okay. So right here and right here is where the function is equal to 0. Okay. So right there and right there. So that is x equal to -2, and that is x is equal to 3. Right? I'm just going to color code the graph. It's negative when it's below the x-axis, so I'm going to color it in red, and it's positive when it's above the x-axis. Right there. My question was, or our question was, when is the function less than and equal to 0? So between what x values is my function less than and equal to 0? What would you say the answer is? Rebecca? Right. Okay, so you can see that in between here, these x values, the function is below the x-axis. So the answer to my question is when x is less than or equal to, because you want to know when it's equal to 0, 3, or greater than or equal to -2. Remember, I wouldn't write it like that. It's totally fine to write it like that. I'd write the answer as -2 to 3. You want to include the -2 and the 3, so I put square brackets around. Okay. Any questions on doing it graphically? So graphically is pretty straightforward, right? If I give you a picture of a function and I want to know when it's greater than 0, you just look for the parts where it's above the x-axis. If I want to know where it's less than 0, you look for the part where it's below the x-axis. And if I want to know when it's equal to 0, you look for the part where it crosses the x-axis. Pretty straightforward stuff. Okay. So back to here. So the answer to this question was between -2 and 3. Right? Or again, if you don't like writing it like that, write it like this. Whichever way you want to write it is fine. Whichever one you feel comfortable with. Any questions on this? So ultimately, what we want to be able to do is to solve, so I should have said here, solve by graphing. We want to be able to solve without graphing it. So I want to be able to solve when a function is greater than 0 or less than 0 or equal to it without having to graph it. So we'll start off with this function here. I want to know when the function -4x bracket x plus 2 quantity squared times x minus 3. I want to know when is that less than 0. So if I go back to my graph just for a second, looking at that other one, the function is either above the x-axis or below the x-axis between the intercepts, right? Because here's the intercepts, so it's either below or above. So what I need to find first is, what do you think I need to find? If the function can change from a positive to a negative at the intercepts, what do you think I should identify? Yeah, the x-intercepts. And it's pretty easy to find the x-intercepts from this guy because it's already in factored form. So to determine the x-intercepts, I just take each one of the factors. So the first factor is -4x. Set that equal to 0. Solve. X is equal to 0. My next factor is x plus 2 quantity squared. Take the square root of both sides. Square root of 0 is 0, so I end up with x plus 2 is equal to 0. So my second x-intercept is negative 2. And then my last factor is x minus 3 is equal to 0. So solving, and I get x is equal to 2. So in between these x-intercepts, my function's either above the x-axis or below the x-axis. And I want to figure out where it is. So I'm going to use something called an interval chart. An interval chart is an integral way of determining when a function is positive or where it's negative. Any of you going on to calculus and vectors, very important concept in interval chart. So what I want to do is I want to go from negative infinity all the way to positive infinity. I want to write down the intervals. Okay, so my first interval will always start from negative infinity, and then I go up to my first intercept I would hit. So which one's the first one I'm going to hit moving along to the right? Right, negative 2. So this is my first interval. So either my function is positive or negative at this interval, because I know at negative 2 it's equal to 0. And then from negative 2 to my next one, which would be 0. And then from 0 to 3, and from 3 to positive infinity. Does that make sense how I blocked off my intervals? So I'm testing the function between my x-intercepts. And what I want to figure out is if my function's positive or negative. So I'm going to do it in a quick way of doing it, where I'm going to write down the factors that make up my polynomial. My first factor was negative 4x, so I write down negative 4x. My next factor is x plus 2 quantity squared. Then my next factor, or my last one, was that x minus 3. Okay, so all factors have to be represented here because whatever this is times that has to give you your original polynomial. And I can see that this times that is my original polynomial, right? Okay, so now we're going to fill out this interval chart. We're going to fill out this interval chart by doing some mental math. Okay? I don't care what the answer is. I only care whether the answer is positive or negative. So if I take a number in this interval, what would a number be between negative infinity and negative 2? Julie, a number between negative 7. Already said, right? Negative 7 times negative 4. Is that a positive or a negative answer? David? Positive. Negative 7 plus 2 squared. What's that work out to be? Anybody? Yep. Positive. Negative 7 minus 3. What's that work out to be? Yep. Negative. So this factor times this factor times this factor will give me the sign of my function. So a positive times a negative is a negative. And I'm just doing it in different colors so you can see the different factors. Okay, now fill this one in. A number between negative 2 and 0 is negative 1. Negative 1 inside of here will give me positive. Negative 1 inside of here will give me positive. Negative 1 inside of there will give me a negative. A positive times a negative is a negative. Anybody have no clue what I'm talking about? Okay, all I'm doing is taking a number in this interval. 1's a nice number, plugging it in here. And then I'm figuring out the answer. All I'm writing down is the sign of the answer. 1 plus 2 squared is a positive. 1 minus 3 is a negative. So then I'm multiplying a negative times a positive times a negative, which is a positive. 10, putting it in here would be negative. That would be positive. 10 minus 3 would be a positive. So negative times a positive is a negative. So my original question was, when is this polynomial less than 0? It's going to be less than 0 when we have negative signs, right? So here's my answer right here. It's going to be less than 0 between negative infinity and negative 2. It's less than 0 between negative 2 and 0. And it's less than 0 between 3 and infinity. Does that make sense? So if I graph this function, right, it'd be the only time it would go above the x-axis is between 0 and 3. Every other time it would be below the x-axis. So then I'm going to write down the answer to my question. My question was, when is this polynomial function less than 0? Well, it's less than 0 when x is between negative infinity and negative 2, negative 2 and 0, and 3 to positive infinity. Does that make sense? So now I can answer this without having to graph it. So say this was the answer to my question, right? Which obviously it is. And then I wanted to be lazy and say, okay, since this goes from negative infinity to negative 2, and this goes from negative 2 to 0, can I just combine these guys and say from negative infinity to 0? Instead of writing these two down, can I just write, would that just mean the same thing? Exactly. It's not including, so here it isn't including 0 because I have the round bracket around it. Which one am I including here that I shouldn't do? Okay? Negative 2. Okay, so if I do this, this is telling me that negative 2 is in this interval, but I can't include negative 2 because it's equal to 0 there. Okay? So be careful about that. Okay? If the question was, when is it less than or equal to, then you can combine it into one if you want. Any questions? Okay, so these questions become harder when the polynomial isn't given to you in factored form. So the only difference is you have to put it in factored form. So let's just try one of those. And I'll throw in something different here so that if you know what to do when you get a situation like this. Okay, so whenever you're solving an inequality that the degree is higher than 1, so a quadratic inequality, cubic, quartic, quintic, whatever it happens to be, one side always has to be equal to 0. Okay, so if it's not equal to 0, make it equal to 0 by collecting like terms on one side of the equation. Okay, so really this is our question here. When is this polynomial function greater than or equal to 0? Okay, so I don't know when it's greater than or equal to 0, so I have to find the x-intercepts. Okay. How do I find the x-intercepts? I find it by factor. How do I factor a polynomial that has 4 terms? I do it one of 2 ways. I do it by grouping, and if grouping doesn't work, what do? Right, well, we learned in 3-4, okay? So you would guess a number that would work, right? And again, you're just guessing. When I say you're guessing a number, what numbers am I guessing again? Yep. Right, factors of 6. And again, just like on a test, right, start with 1, negative 1, and so on, okay? Just don't randomly guess, have some sort of pattern. And luckily, this worked out. So when I used 1 as what I was dividing through by, what was I dividing by? What was my binomial divided? Right. So I'm left with x minus 1, and then my quotient was x squared minus x minus 6. And again, it's still an inequality. I've just changed this polynomial into this polynomial. And then I look to see if this guy factors. If it does, great. If it doesn't, then I'd have to do some work to figure out my intercepts. But it does factor. It factors to that, and that's the minus and that's the plus. And again, right, bless you. Again, whenever you're factoring, just take a minute and make sure that you've done it correctly. So this times this is 2x squared. This times this is 3x. This is negative 4x, and that gives me my negative 1x, and that gives me negative 6. So now that I have it in factored form, it'll be pretty easy to identify my x-intercepts. So my x-intercepts is when the factors are equal to 0. So 1, 2, and negative 3 over 2. Anybody unsure where I got those numbers in red? I'm just setting each one of those factors equal to 0 to find the intercepts. So now that I have the intercepts, it becomes exactly like this where we do our interval chart. So I set up my interval chart, starting from negative infinity to my first x-intercept, which is negative 3 over 2, and then from negative 3 over 2 to 1, and then from 1 to 2, and then from 2 to positive infinity. And again, if you don't like the bracket notation, right, you can always write it this way. Feel free, whichever way you feel comfortable with doing it. Okay, so whichever way you want to write it. Okay, but remember, one of the common mistakes people do when they do the interval chart is to put square brackets around this or put the equal sign. You can't do that because you're testing between the intercepts. Okay, you're not testing at the intercepts. You already know it's equal to 0 at those values. So then once you've set up your interval, then write down your factors. Okay? And again, it doesn't matter the order in which you write down your factors because multiplication doesn't matter the order in which you multiply. You get the same answer. So those are my 3 factors. And those 3 factors multiply to give me my original polynomial. Okay, so you can write down this polynomial, you can write down the factors, it really doesn't matter. I'm just going to write down the original one so you know it's different from the first one, and you can write down either one. Okay, so now it's just a matter of completing this interval chart to answer your question. So you're taking any number between negative infinity and negative 3 over 2, so negative 10, put it in here, negative, 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 3 negatives multiply to give you a negative. A number between negative 3 over 2 and 1, a nice one is 0. Negative, negative, positive, they multiply to give you a positive. 1.5, 1.5 minus 1 is a positive, 1.5 minus 2 is a negative, 1.5 times 2 plus 3 is a positive, that's a negative. And then any number greater than 2, 7, positive, 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 that's positive. Question. Okay, so now you just look at your interval chart to answer the question, when is 2x cubed minus 3x squared minus 5x plus 6, when was that greater than or equal to 0? And you would say the answer is, anybody? Yeah, so between this right here, right? So I write between, so when x is between negative 3 over 2 and 1, do I want to include those numbers or not include those brackets? Or how do I even know the brackets? Do I want to include those numbers, not include those numbers? Does it matter, Jordan? Yeah, right, because I want to know when it's greater than or equal to 0. I want to include those numbers because it's equal to 0 at those numbers. So that one, and this last one here, which is from 2 to infinity. So we want to include 2. We can never include infinity because it can never be achieved, so it's always a round bracket. Yeah, but we want to know when it was positive, right? Right? Is that good? Okay, and that's pretty much about as hard or as easy as this stuff's going to get. Okay, you identify the factors. If it's given to you in factored form, then identify the zeros, write down your intervals, write down your factors, make sure that everything is included. A common mistake people make is if this was it, they write this down and forgot to put the squared. You have to write every single thing down here, Katie. I used round brackets here because I wanted to know when it was less than 0. So the intercepts weren't included. But in this guy, I wanted to know when it was greater than and equal to 0. So I had to include the zeros. Make sense? Okay. And if it's not factored, then factor it, and then it becomes the exact same question. Okay. So I'm going to save this. Again, if you're ready to write